Go
So
ahead.
to write your memoirs, what sort of like what was your like did it kind of evolve naturally? Was it something you did intentionally? Was it did you have an idea that you would go to the proposal stage or
Yeah, I had been thinking about a book that combined stories of exploration with my own funny experiences and things that I learned along the way. And so I wanted to write this down for a while, mainly to connect with people who also didn't have the straight shot from, kindergarten to scientific career. And so then I happened to find an agent who really liked the idea. So that's how it came about.
Very cool. I was a Radcliffe Fellow 2 years ago,
Nice.
and there was a lot of people that were writing books, and we met also with agent. It was very interesting to see the process of putting up a book, and people took really a year to stop everything to do it. Yeah. You know who also is in your team that I go way back is Rona Oran.
Oh,
She
yeah.
was in me. Yeah, that's also nice.
Nice.
Connection. I think we are going to start. And what I'm going to do is share my screen. So welcome everybody to another SHIELD webinar. We're very excited with our speaker today. So let me share my screen. And what usually we do, I just give a quick overview of what SHIELD is about. And then I introduce our illustrious speaker. So SHIELD is one of the DRIVE NASA centers. There are 3 of them funded. This was part of the recommendation from the last decadal survey to have centers very much like in other agencies, like in NSF, try to tackle breakthrough ideas that need a center, need a larger investment at a single proposal to try to solve a major problem. And so SHIELD is related to the heliosphere. And here I'm going to play a movie we produced that show all the planets that surround the sun embedded within this large structure that is a heliosphere that protect us and probably had a lot to do with the evolution of life in our own planet. So SHIELD main questions surround the structure of this bubble that shield us from particles and radiation from the galaxy. And the vision of SHIELD was to create a twin analog, to try to put together theoreticians, observers, modelers, to try to tackle one of the outstanding questions that we don't understand on how this SHIELD evolved and the nature of the SHIELD. And you can go to this website. We have a very nice website that describes all the research and the broader impact activities that we have. Here is just a diagram of some of the questions we are trying to tackle, just to give an idea of the complexity. We have 4 research thrusts in the center. One of them surround even the shape of our own bubble, the heliosphere. We don't know. So what is this global structure of the heliosphere? We also don't understand how the solar wind behave at large distances. The solar wind at large distances is vastly different than the solar wind near the sun, and beyond 10 AU is heavily modulated by the neutral particles that come from the galaxy. They create a thermal component that we call pickup ions, and we don't really understand all the processes that lead to their creation, how they evolve, how they affect the solar wind, and they become the dominant energy at large scales. So we really need to understand that, and especially in the subsonic region where the solar wind go to smaller speeds, we need to understand the behavior of this hot component. And you can see here there is lots of processes that affect the solar wind, from kinetic processes that somehow need to be ingested and incorporated in global models. we also don't understand how far the heliosphere influenced the galaxy. So we don't know how far the heliosphere interact and influence the interstellar medium. And again, just to put in context, we have for the first time an in situ measurements of this region. And so this is the first time we have in situ measurement of any other bubble around stars. So we are trying to understand how far this influence extend. And finally, we know that the heliosphere shield almost 70% of the radiation that come from the galaxy. It's a #1 radiation that influence astronauts in long time travel past 3 years. And we really don't understand how it's entered the heliosphere. So it's another question we have. We have lots of institutions involved. Is actually it's international, a lot in US, but we have also collaborators in other countries that are involved in the SHIELD effort. And a big part of it is a broader impact that is not just a separate effort, but the idea that is closely interwoven in the formation of the team, in creating a diverse and inclusive voices to solve the science questions that we have. And we have lots of efforts here, and the SHIELD webinar is part of it. We also have a effort that we will ramp up now in phase 2. We had it very strong in phase 1 on asking people to give their testimonials of what their trajectory was. And this, percolate all the way to leaders like Lindy that is going to talk to us, why you can have not a straight shoot trajectory and still be extremely successful. So we called it, you can be what you can see. So we had lots of testimonials of students not directly involved with SHIELD, but they told their own path. So we have these snippets in our website. You can go and check. And if you're interested to share your story, please contact us in SHIELD Outreach at bu.edu. And here is a Broadening Impact team. We have other SHIELD webinars. So usually the 3rd Friday of the month, but it's not every month. We're going to ramp up in the fall for more events. We have Sarah Gibson in September. Then we have Cheryl Moore giving, it's an unusual 2 webinars in the same month. She's going to talk about the preparation for the eclipse. And in October, Lika Kwatakuta, that led the Living with a Star and was a major force behind the Sun-like star effort at NASA, is going to talk about the eclipse experience. We also have an ongoing coffee chat. So if you are an early career, please contact us, because this is a place where Nick Ross, that is a deputy director of SHIELD, is running it. And I know I'm not welcomed because PI and senior people are not welcome, for a good reason, because we want a safe space when the students in early careers can talk about us and can talk about challenges that they have. So anyway, the coffee chat will restart in the fall. So contact us if you're interested, and find us in the web. We have all Twitter, Facebook, now Instagram, and please just send an email to us. So without further ado, we have our speaker, Lindy Elkins-Tanton, that is a PI of the NASA Psyche mission. She is at Arizona State University Vice President for Interplanetary Initiative. Her research concerned the formation and evolution of rocky planets and processes for education for future of the society. She had led 4 field expeditions in Siberia. I'm very jealous of that. She had an asteroid 8252 named after her. In 2018, she was elected to the American Academy of Art and Science. In 2021, she was elected for the National Academy of Science. In 2022, she published her memoir, A Portrait of a Scientist as a Young Woman, and I am myself very eager to read it. Anyway, welcome, Lindy, and thank you so much for agreeing to give this webinar and chat about your path and your experience. So I'm going to stop sharing, And the floor is yours.
Now I will start sharing.
Okay.
So let me bring up my PowerPoint
Mhm.
and put it into presentation mode. You can let me know. Are we there?
Yes, you are.
Perfect. Okay,
Perfect.
great. Well, I start with this picture just for the very reason that you said that I think that there's often a myth that scientists know from their childhood that they're going to be a scientist. And I do often ask people when I give public talks, what was the moment where you became very interested in astronomy or planetary science? And very often I get the answer, I saw Saturn through a telescope when I was 10, 11, or 12. That is an absolutely life-changing experience based on my non-scientific gathering of data at public talks. And I'm here to say that I saw Saturn through a telescope when I was around 10, but I still wanted to be a veterinarian. And so here I am at age 7 learning to ride, and that was my passion. This little white pony named Barney was my first ride. And he didn't belong to me, but he remains beloved in my memory because he was the first pony that I rode. So I did not know for sure that what I wanted to do was become a scientist. During my 20s, I worked in business. I worked as a management consultant, and I ran my own company for a few years, writing business plans for young high-tech ventures looking for venture capital. And it was through that experience that I learned how important it is to know things about how teams work and what leadership is and how to write a budget and how to do risk analysis and how to schedule things and how to deal with HR problems. Because it turns out that every single thing we do as humans is an endeavor of humans. And so working with humans is actually often the hardest part, harder than the tech part. And so I'm very grateful for that time that I spent. But I also like to share that, so in this picture, I think I'm maybe 32 or 33. And I went back for my graduate degree when I was 31. So 10 years after what would be expected, I went back to MIT for my PhD. And I was at that time a single mother. And I was also suffering from anxiety and depression. And what I later found out was PTSD. And it took me a number of years to unravel that and work through it and become a stronger person. And I share this because I know that it's unfortunately a common human experience. And I'm sure there are people here today who've had some aspect, and hopefully not all aspects of this experience. And important to know that that doesn't preclude you from your scientific career or whatever it is. And also that you can start late and still be fine. And so I was not the picture of success at that moment. And so here I am halfway through my PhD up in the Sierra Nevada collecting rock samples. And so that's kind of my image from that moment when I was turning the corner, so to speak, in my own life. And so things did turn out fine. This is my son graduating from college, and I was on faculty at that time and able to give him a hug as he walked across the stage. And so you know, he's now 31, and so time goes on. And it's very fascinating to look back and feel like I can tell a straight story about ending up in different kind of scientific leadership positions as I am now. But I think one of the things that's disappointed me about other memoirs that I tried to kind of overcome in my own is this image that you're just ascending a mountain and then pretty soon you're in something that's called success. But you know, moments of positivity are fleeting, just as moments of despair are fleeting, and all of our lives are kind of a roller coaster. And so writing a book that says, you know, I started out and I knew where I was going and I walked down this path and here I am is so misleading. And so, you know, who knows what tomorrow might bring. And so that's what I was trying to do, is bring this kind of story of humanity to our real pathways. But one thing that was true throughout my life is that I've been really fascinated by exploration. And this is a picture of Antarctica, of course, discovered about 200 years ago. And as a kid, even, I read all the stories of the Arctic and Antarctic explorers and the early Europeans to go to Africa. And I began to learn about the tragedy that is to be an indigenous person in a place that is considered to be discovered by another people. But I always wanted to be an explorer, and Antarctica is such a great example of why we explore. I think we explore just because we can't help ourselves. We just are dying to see the thing that hasn't been seen before. We want to see what's over that hill. I think it's in the human genome. Because you take a look at Antarctica, and this is not an inspiring place. You just know you're not going to be comfortable. This is not a business proposition. You know, you're not going there to discover gold or people to trade with. It's pretty unwelcoming. And yet the race to the South Pole was on. And it led to this picture, which I think is the most tragic photo in all of exploration. This is 1911 when Scott's team reaches the South Pole only to find Amundsen's tent left there to let them know that he got there first. So this was the day that they realized they were not the first to the South Pole, even though they made it. In fact, Amundsen even left a letter in the tent for them to find, to point out that he was there first. And then, of course, really tragically, the whole Scott team died on the way back to their base camp. And so this is the kind of drive we have to explore. And it took me a little while to realize that exploration is one of the things that traditionally and to this day is quite hard for women, minorities, or people from other underrepresented groups to really participate in. But nonetheless, as was said, I did end up, when I was early faculty, winning a grant to put together a team of 30 scientists from 8 countries to try to understand how or why the Siberian flood basalts, the largest flood basalt eruption on a continent in Earth history, might have caused or simply been coincident with the largest extinction in Earth history, the end Permian extinction 252 million years ago. I do think that over the course of these 5-6 years of funding and then all the follow-on work, I think we did pretty much tie a bow on that problem, which has been worked on by many people in hundreds and hundreds of papers written over time. And I think we put some things together, but there I am in an absolutely dire little inflatable boat on the Kutui River, way up above the Arctic Circle in central Siberia, having an adventure. And that's my tent, which it just makes me nostalgic still to look at these pictures. And this is how we cooked our breakfast and our dinner. And this was how I learned that that traditional Russian field geologists do not have lunch. You just do all the work you can for as many hours of your 24 hours of daylight that you can, and then you eat another meal and go to bed. And so we started asking for something in the middle of the day because us soft Americans were used to a meal in the middle of the day. So we would have a candy bar. But these, just amazing experience with great colleagues, and other parts of our team were in other parts of the world, investigating other parts of the story. There were lots of mosquitoes. This was just an odd snap of my leg during a snack break. And then besides the work on the rivers, because most of Siberia is just an endless landscape of trees and sphagnum moss bogs like what you see here. Almost all the rock outcrops are on rivers, so mostly we're on rivers, but you can see in the distance where the snow is, that's where the next rock outcrop is. It's about 15 kilometers away. So that's me in the back hiking up this hill, the last one to make it up to some rocks that I'd wanted to see my whole life back in 2008. And so that was a tremendous experience. And what it got me really thinking about was, what is it to be a scientist, and what does it mean to do important work? And I started thinking about this thing that I call the hero model. This is the traditional model in academia where one faculty member, the hair doctor professor, owns that field at that university. And I think of it as owning a mountain or a pyramid of resources and people, positions, and buildings and money. In sort of the German tradition from the 19th century, it was kind of perfected there. And knowledge is gained by adding increments around the base of that mountain. So you incrementally step forward with your own field until it bumps into the next mountain. And then if you continue, then basically you get into an intellectual fight with the owner of that adjacent mountain. And I think that this hero model has really served us well for a millennia. But we're past the stage where we can, for example, discover new chemistry in our kitchens. And I worry several aspects of this hero model. One is that the people who work in this pyramid are dependent upon the hero leader for everything, including how their HR practices are. And so it can be a place where bullying and harassment can occur unchecked, as we all know. And it also can be perhaps not as diverse as it should be. And also I worry that it means that we're not actually answering the biggest questions. And so what you're doing at SHIELD is a great example of asking a big, audacious question that requires people from many disciplines to think about it. And so this is what I've been working on. I wrote a big essay about this back in 2021. Is it time to say goodbye to our heroes? Talking about other ways to put together teams. And so the way that we're working on is called Big Questions. And in the team model, there's a goal question exterior to everyone on the team rather than a question that's held within that leader. So we've worked on something over about 6 years, a process that I invented back in 2016 to start by brainstorming the biggest questions that we need to answer, and then allow people to volunteer into teams, and only later to choose a leader. And then we give them seed funding and we set them under project management. And there's a few more steps, but that's basically what it is. So we've seed funded 40 teams now in the last 6 years through Interplanetary Initiative at Arizona State University. And they all include outside partners, government, other universities, private sector, members of the community. And we give them that little bit of seed funding, very little, and give them project management. And then we encourage them to take those pilots and go for philanthropy and grant funding. And right now we're running at an 8 times return on investment for our seed funding. So I'm very excited about the kind of model that you all are doing and that we're doing here, where you go after very important questions, because I would say we don't have time as society to be slow or to be busy building our own fame or charisma. Instead, we have got to solve the biggest problems that face humanity. We've got to solve them faster, and we've got to solve them without a lot of personal hubris. And so I think these are all steps of positivity. And so soon enough, I found myself, since I'm a planetary scientist, thinking about space exploration. And so this is just a little reminder for you. This, of course, is the moon. This is the limb of the moon. This is the Orientale impact basin on the limb of the moon. We can't see it from the Earth, but isn't that a gorgeous multi-ring basin? I always say if you don't have a favorite lunar basin, I recommend Orientale. So Orientale is on this lovely rocky body, rocky like the Earth, and we've sent people and lots of robotic explorers to it. And of course, we have an entire army of robotic explorers looking at Mars, another rocky planet. This is the Burns Cliff, named after Roger Burns, mineralogist who hypothesized what Mars's surface might be like and what minerals might be present in great accuracy, actually. And I took all the courses of his that were offered when I was an undergraduate, and later I inherited his lab, which was such an honor, because he was just a great human being, a lovely, lovely person, and a great scientist. So another rocky body. And then, of course, we visited via our robotic partners, gas giants like Jupiter, and icy bodies. But something that we've never been to yet is a body with a metallic surface, which is what we think the asteroid 16 Psyche is. We think that it has a largely metallic surface and consists at least partly of metal. And I'm going to say that the reason that I ended up being the PI of this proposal really stems back to my obsession with teams, because I think the most important thing we can do is figure out how to work together better, such that our teams not only have better and faster results, but that they're a better experience for every individual. So this is a very small part of our team. Right now we have about 350 people on the team spread across more than a dozen institutions. At peak, we had 800. Over time, we've had over 2,000 people work on this project, and started working on it back in 2011. And so the small part of our team we can see is a bit more diverse than the average aerospace team. And part of the reason for this has been that we've worked very, very hard on our culture. I think the most important first thing in team culture is that every person have a voice. We have this Psyche mission, which is the best news is bad news brought early, because you need to limit risk. You need to know what's wrong early enough that you have a chance to fix it. And the only way you can do that is if you respectfully listen to the most junior people on the team who authentically know what's actually happening in the trenches. All too often, it's only the leaders that get to speak. And so I will also point out that this is what in literary circles might be called foreshadowing, because we missed our launch date last year. And I'm going to talk a little bit about that because it's an incredibly important lesson learned. All right, so this is just my reminder to you that we do not know what Psyche looks like. That's why I had an artist's interpretation of Psyche there on the previous page. We have no photos of it. In fact, this is Psyche right here, as seen from my backyard, but even in the, in the 60-inch at Mount Wilson, it doesn't look much bigger. It's only 4 pixels in Hubble. It's a small body far away. And so it's about this big. In fact, it's the size of Massachusetts without the Cape. Since I spent the majority of my adult life in Massachusetts, although I now live in Arizona, I like to show the size of Psyche this way. The surface area of Psyche is about the same as the surface area of California. And so in the end, we're going to orbit for 26 months. And you can imagine flying over the surface of California for 26 months and then trying to understand its history that way. That's basically what we're trying to do with this asteroid. Where is it? So here's a picture of our familiar solar system from the sun just out to Jupiter. And the purple, of course, is the main asteroid belt and 1.5 million asteroids in there. And then the Trojans that are at the Lagrange points around Jupiter. And so this is where Psyche is. It's in the outer main belt. At its closest to the Earth, when Earth and Psyche are on the same side of the sun, it's about 250 million kilometers away. And at its farthest, when it's on the far side of the sun, it's about 650 million kilometers away, which means actually at 250 million kilometers closest approach, Mars comes 3 times closer to the Earth than does Psyche. And so why am I pointing this out in particular? It's because I wonder if any of you have seen these headlines, of which there have been many, that Psyche is going to make us all rich. And so here's one from Forbes. NASA will launch the Psyche mission to explore the asteroid worth more than the global economy. And Smithsonian, this metal-rich potato-shaped asteroid, could be worth $10 quintillion. Okay, so maybe some of you have seen these headlines. There have been many, many, many of them over the years. Because in fact, if we were able to bring Psyche safely to the Earth, which we are absolutely not able to in any way, we have zero of the technology to do that, then in fact, if we could sell Psyche on the 2017 metals market without flooding the market and making it worth $0, which is what would happen, it would in fact be worth $10 quintillion. And so that's kind of fun, but it's a lovely headline with absolutely zero truth in it. But even Forbes can't resist. And Jamie Carter, who's the senior space contributor to Forbes, I've talked to him about this, and he's written other articles, and he's kind of clarified, but he said that he can't resist putting the money aspect in there because it gets him more readership out of Forbes than he's ever had before. So it's just kind of hilarious, I think. But I'd like to point out that Katie Camaro and the Miami Herald worked really hard to get this right. And so asteroid Psyche isn't going to make you rich and is never going to hit the Earth, but we have another reason to visit, which is fundamental science. And so the question is, what do we think that Psyche is, that it is this singular metallic object? And in fact, objective A is to determine whether Psyche is a part of the metal core of a planetesimal, or if it is primitive unmelted material. We don't really know what it is. The thing is, there are only about 9 asteroids known that seem to be made primarily of metal. And we don't really know until we get there. And so the other thing that I always remind people of is that probably all the science I tell you about today is going to prove to be wrong when we get there. But that is the excitement about studying space. And I know you all know that perfectly well, that the natural world outstrips our ability to imagine every time, no matter how clever that we think that we are. And so the idea is that, and probably many of you know this already, that in just the first 1, 2, 3 million years of our 4,568 million year old solar system, material clumped up into things called planetesimals. These are bodies the size of cities or continents, and a lot of them heated from the short-lived radioisotope aluminum-26 to melt. And what started out as intimately mixed silicate and metal, the metal melted and sank to the middle to form a core. And so some of these early planetesimals, we know this from meteorites, some of these early planetesimals differentiated to form a metal core and a rocky exterior, just like the same structure as our rocky planets today. And so those thousands of planetesimals collided together, as in this picture, and some of them accreted to form the rocky planets that we have today, and others of them ended up broken and stranded in the asteroid belt. And so that's what the asteroid belt is, of course. It's the shrapnel that's left over after planet formation. And you also probably know that the meteorites that fall to Earth are almost without exception very recently broken off something in the asteroid belt. And there are a few of them that come from Mars or the moon, and some whose sources we haven't discovered yet. Maybe they come from Venus or Mercury, a little harder to throw it out to the Earth from there, but possible. But almost all of them come from the asteroid belt. So they are, in fact, our sampling of the asteroid belt, which is, in fact, our sampling of the first few million years of the solar system. So we think that Psyche is most likely to be a planetesimal, like one of the ones in this picture here, that through collisions had some of its rock stripped away, leaving it largely made of metal. But it's a singular object. It's it's the largest of those 9 asteroids that we think are maybe made of metal. It's the only one that's kind of roughly round. It's sort of potato shaped. And we had to tell this story in our proposal process in order to convince the review panel that we had something interesting to go look at, because the common misconception about asteroids is that they're basically all the same, and you've seen one, you've seen them all. But of course, every asteroid we go to see, we discover something quite entirely different. So we constantly, through the proposal process, which is a 3-year multi-step competition process to win these missions, trying to tell the story. So this is the cover of our step 1 proposal. It was 218 pages written by 40 people. And we submitted it in 2014, trying to tell this story. So here's an impact. And here's the cover of our step 2 proposal, because we competed with 27 other proposals and were down selected to go to step 2. There were 5 of us who went to step 2, and we were then allowed to write a 1,000-page concept study report with 150 people who worked on it. And this is the cover of our step 2 proposal. It's that same impact, maybe 30 seconds later, with the impactor screaming off to the bottom left, and you could see the red hot core of the planetesimal on the top right beginning to be revealed from under the rocky streamers. So again, we're constantly trying to tell this story. And so then I'm just going back. So then quite to my astonishment, in January of 2017, I got a call from Thomas Zurbuchen, who was then the lead scientist at NASA, the AD for all of the science operations, saying that we were selected for flight, which was quite a life-changing moment. And the next thing he said to me was, I want you to completely repropose your student collaborations. Now, the thing about student collaborations on these big missions, you get a percentage of your budget to spend on student collaborations. But if you write a student collaboration that could possibly risk the purpose, the main science purpose of your mission, it will be listed as a major weakness. And so at this time, this is changing, but at that time, for example, we couldn't really propose to fly a CubeSat because that CubeSat could be a risk to the primary mission. And so you're never going to let your student collaborations risk your primary mission, because that means you're not going to be selected. So you do a really safe student collaboration proposal. But we were thrilled to propose something more audacious. And so Cassie Bowman, who runs all of our student collaborations for us out of ASU, she's a Ph.D. in education and has tons of work with NASA on student outreach. We proposed 10 ideas to NASA, and NASA ended up choosing 4 of them. So we have a very big undergraduate senior capstone program where we actually get teams that mimic actual teams in the real world, because a lot of times interdisciplinarity is very narrow in a student capstone project. But ours, we try to get our partner institutions to have a student project manager and a student UI UX person, a student graphic designer, a student engineer, all together working on these teams. We also have free online courses called the Innovation Toolkit. They're available through our website. And we have an art intern program. We run a competition every year, and we choose 16 undergraduates, and then we fund them to make 4 original works of art per year. And so already we have over 325 works of art, and it's just so great to see the artists and the students and the engineers and the budgeters and the schedulers and everyone else that's needed, because of course it's not just engineering and it's not just science, it's everyone together is the point. Everyone's discipline is required. Everyone is respected, everyone talks. So these are 2 pieces of work from our Psyche inspired work. One is the graphic in the background, and the other is this platter, which is, it's as big as my arms if I hold them in a circle. It's a great big platter done by this amazing ceramicist who wanted to see if he could mimic a metal surface using his glaze. And the glaze that he created included thermite, which is an iron-bearing, super exothermic, perhaps explosive material that he used for his, and luckily I found out afterwards, and everything was okay. No one was hurt and no explosion occurred, but he made a great platter, which I love. And so just encouraging you, check out our website. We've got all the art up there. We've had everything from symphonies to chalk art, cooking, jewelry, everything. It's really, really fun. And so over the years that we've been doing this since selection, we've had over 1,500 undergraduates at 58 colleges and universities participate. So something we're also very proud of, just like Shield's work on connecting across disciplines and up and down through seniority. So we are going to launch this fall in 139 days from Kennedy on a SpaceX Falcon Heavy and re-land the side boosters. I'm super excited about this. But wait, we were supposed to launch last August. And so what happened? Well, partly what happened was COVID, because all of the major parts of putting together this mission happened during COVID. Now, this is a big mission. The budget is over $. We have dozens of partners. And we built the entire spacecraft, complete working spacecraft during COVID, including months when Jet Propulsion Laboratory was completely shut down and closed and no work happened. I mean, the team was heroic. And through all the existential risk and the fear and people being sick and being home, we actually almost made it. And so it's actually, to me, a story of incredible success, except that it was a failure. And the proximate cause of why we didn't make it to launch was that we were not able to finish testing our guidance, navigation, and control software. And the reason we were not able to finish that is because of a breakdown in team culture. And this is why I want to say this. It's incredibly important to make it possible for everyone on the team to speak. And so this team really needed help, and they needed more senior people. But as they asked for help and talked about their need and their stress, their managers brought the news upward through 2 or 3 levels of leadership, but each time it was a little bit stripped of its urgency. And you can imagine how this goes. One person speaks to you with great urgency, like, I can't take it anymore. Everyone's working 3 shifts. I'm exhausted. We're not going to make it. And the news from the manager is, well, the team is feeling stress and they're worried they're not going to make it. It seems like we could use some more resources. And then the next one is a little bit less emotional and pointed and specific. And so actually, we didn't know how much trouble they were in, which was a gutting realization for me. And I learned a lot of things through this. One is that it is literally crazy of me to think that as an outsider, I could change the culture inside an organization, even though officially I'm sort of their customer from Jet Propulsion Laboratory. It's a great place, but everybody has their own culture, and trying to make a united team across hundreds of people and dozens of organizations is incredibly hard. So I would say we succeeded 70, 80% with the team culture. And very sadly, it caused a lot of trauma to these people where that culture failed. Now, of course, it wasn't the only thing that wasn't done, and there were a lot of things we needed to do better. So we've been using this team this year very, very well with a really reformed and re-energized team. And so our new launch period opens October 5th. And we, at this moment, are feeling very, very good about hitting that 10:38 a.m. Eastern time on October 5th launching. But we'll see, there can a number of emergencies could happen between now and then. But so far looking good. So we're gonna swing out and then back in, get a Mars gravity assist in 2026 and end up at the asteroid in 2029. And so that's our plan. I want to show you just a few hardware pictures. This is me and Henry Stone, our project manager in the clean high bay at Jet Propulsion Laboratory when we got our beautiful spacecraft in. It was shipped down from Maxar in the Bay Area, where they built the bus, which is what this is called. The structure and the power system were built by Maxar, our industry partner. The big silver thing is, of course, our high gain antenna. And the red things are, red always means remove before flight. And those in fact are covers on what do you call it, radiator panels. And so then at JPL, it was integrated. And so, in fact, you can see the boom on the top right, just under the edge of the flag. You can see the 2 bumps on that boom are our magnetometers. And that's what Rona Oran, who's Murav's friend, works on, the magnetometry team. And So our propulsion system is Hall effect ion thrusters. It's a solar electric mission, meaning that we harvest solar energy is our sole power source, and we actually move the spacecraft with ion thrusters that run on xenon. And so those two red caps in the bottom are removed before flight caps on the thrusters, and the thrusters are on that white arm that has the equivalent of sort of a shoulder and an elbow, so you can move it out from the spacecraft. And there's another one on the other side. So in total, we have 4 thrusters, even though only one will be running at a time. And this is what they look like on the right in regular light, and on the left in a vacuum chamber practicing. And so they run on the noble gas xenon, and we'll be flying something like 1,070 kilograms of xenon. And when xenon gets ionized and sent through a potential field, that's how we impart momentum to the spacecraft. And ionized xenon is blue. And so that's what it's going to look like in space, which I think is kind of cool. Had to do a lot of testing, you could imagine. So here's the bottom of the spacecraft. That gold thing is the adapter ring that will connect it to the rocket in the end. The bottom of the spacecraft going into the JPL thermal vacuum chamber. So see the 2 people in that picture for scale. On the left, one guy up on the balcony and another one standing at the bottom. And the spacecraft goes in, and that huge door is shut, and then the whole thing is evacuated and then brought down to space temperature using tanker after tanker coming through the JPL gate, all for a whole week with liquid nitrogen. So that was amazing to run all those tests. So that way we can really run the thermal tests and also under vacuum. And here is testing extending the solar arrays. So this is one side. And in fact, those are 3 panels there you can see, and it's actually 5-panel array. The middle panel gets a panel above it and below it, so it becomes a plus sign. But you also see that scaffolding at the top. That scaffolding offloads gravity because, of course, the unfolding mechanism is designed to work in space under 0G. And it cannot work on the ground under Earth G. So to test it, you have to and then to offload gravity for the plus sign test is a whole different setup. So we have to test all these things, test as you fly as best as we can. So when both sides of solar wings are fully deployed, the spacecraft will be almost 25 meters across, the size of a singles tennis court. And those solar arrays will create 20 kilowatts of energy here at Earth, distance from the sun. We shipped it to Kennedy in this beautiful shipping container, which is a little miniature clean room, fully instrumented, so we understand everything the spacecraft went through, and with duplicate generators in case of one failing. And this is it inside of a C-17 transport plane being flown to Kennedy. And here it is coming out of the Kennedy transport plane a year ago. And so it's still right by Kennedy. It's across the water in another aerospace company being held for us while we finish up all the things that we need to do and get ready for our launch in 139 days. And so that's me on the left, and Brian Bone, our assembly test and launch operations manager, on the right, pointing out something with a flashlight under the beautiful spacecraft. And I invite you all to follow us on social media and check out our website, and keep your fingers crossed that all goes smoothly between now and October 5th. When we expect to be launching, and then it'll be a little while to get there, but then we'll be discovering things that nobody has seen before. So that is my presentation, my quick presentation about my little path and the story of the mission. And I'm very happy to answer questions or chat about anything you have on your mind.
Yeah, Lindy, this was so, I love all this. I remember when I started Voyager, seeing this instrumentation and the size of it. Oh my God, it's big.
It's big.
It's big. Voyager was big. This is big.
Yeah, it's amazing.
It's incredible, the size of this. Oh my God.
And I will say just to that point. So the reason that we chose Maxar, this is Maxar's very first time being prime on a NASA deep space mission. And so we had to convince NASA that Maxar was right to choose. But Maxar has put over 1,000 telecommunication satellites into Earth orbit, and they use exactly this power system. And this is their smallest off the line chassis. And the big ones are maybe 4 times bigger than the bus you just saw. They're the size of a whole tractor trailer thing. And that's what's up in space sending us, you know, Netflix and all the rest of it.
I
So
remember
it's tiny from that point of view. Yeah, sorry,
I
go
remember
ahead.
describing Voyager to a journalist, and I said it's like these old fridges, big ones. And yeah, I remember Ed Stone saying, don't say fridge, just like it's a fridge, it's huge.
I know. What is it? What is it? It's like a Greyhound bus. Yeah.
So I have a question for you before I open for people that are attending, if they have other ones. In terms of your role models, I wanted to hear a little bit. You talked a little bit your delayed start and how you overcome some psychological issues. And so that was fantastic that you shared. It's so rare that you see this vulnerable side. So I love that you share. But I'm thinking in terms of, you know, when you were doubting yourself or as you were trying to decide, okay, I'm going to turn the corner, who did you turn to kind of as a role model? And you know, it's so few of, you know, what you say, these hero models look like us or talk about vulnerable or talk about any emotion. So how did you,
Yeah, I know, you sent me this question about role models, and I know that that you have this very good thing, like you have to see it to be it. And I don't think I saw it, you know,
it
someone
doesn't have to be a scientist.
No, I
also,
understand.
yeah,
I'm
it
just
could be
trying to
anybody.
answer the
Yeah.
question.
Yeah.
Yeah, so I don't think that I really saw someone who was doing what I'm doing until toward the end of graduate school, when I was in my late 30s, when I saw Maria Zuber win, because she was the first woman to win a competed space mission, I believe, in any space program in the world, and I was the second to win a competed mission. And so for me, I think during the hard parts of my life, I mean, I really can't think of a role model that I had who I ever thought of as a role model. But certainly, I think all of us see aspects of other people that inspire us to be able to, you know, immediately inspire us to think like, I wish I could do that, or I wish I could be like that. And I will say that one person who's really inspired me through my life was my father. My mother was not a happy person, but my father had the gift of finding joy in small things in the everyday. And to me, that is the best gift you could ever have. It sounds different than what I've been talking about, but it's actually central.
Oh, no,
Yeah, it makes sense to you. How do you withstand the stress? Like, I've been working on this for 12 years. And I intended to be working on it for the rest of my life. And last year, when we had our launch slip, we had to go through something called a continuation cancellation review. Actually, it's called a continuation termination review, where after months and months and months with an internal review board, then you go to NASA headquarters and you present to 90 people for 4 hours. And in the end, they vote. They go around the room and vote, continue or terminate, continue or terminate. So like in that moment, that could have been the end of my biggest project and completely like a big blow to who I thought that I was and my career and other things that one cares about. But if it's possible to hold on to the joys and the importances of what you do every day, then that kind of thing becomes much more tolerable because you really have valued the path. And so that lesson from my father, that I think was the most important role modeling that I ever had.
It's a great, yeah. I phrase it as transcend. There's something in your daily life make you transcend whatever stress you have. So if you play an opera that remind you,
that's it.
That's why. That's it. Yeah. I get that inspiration from science, and so the rest you can keep going no matter what.
Yeah. Opera does it for me too.
Yeah, great, fantastic. Me too. I have more questions, but I don't want to hog too much. And I know I see Ryan here. He has a question. Maybe you can unmute and ask.
Sure. Lindy, thank you so much. That was a wonderful presentation. I find most of your talks extremely inspirational. So thank you for that.
Thanks.
And I really enjoy the idea of the team model. I think it articulates a lot of concepts that kind of exist in the space of collaboration and convergence and now open science. And I'm curious about the disciplines you study to kind of add to that model or kind of be more literate in that sense. And the idea, the one that comes to mind to me for me is collective intelligence. I wonder if you think about that or if that enters into kind of your team model.
Yeah, I have not been I'm slightly familiar with collective intelligence. I haven't read too much about it. And I haven't applied it very much to the team model just because we don't often have a situation where everyone is talking about the same problem at once. The problems tend to be incredibly granular, and so and worked on, with many problem solving teams active at any given time. And so what I've really been focusing on is what are the dynamics inside the room during that very delicate and incredibly crucial moment where the team is talking about a problem. So people's emotions are high because maybe somebody's, found it, or another person feels like it was their fault, and you have to find the right path forward to the most efficient path to solution. But I spend an awful lot of time thinking about what happens in the room at that moment. Who gets to speak? What is their tone? Who listens carefully? Who is the arbiter? Who is the facilitator? And in fact, I'm writing a book proposal about that right now because I think it's so critical. Also, not just for solving the problems so that they get solved, but also for equity and diversity. And the thing I'm always talking about, and so I guess my answer to you, Ryan, is I spend a lot more time reading the sociology and literature, and reading things like out of Harvard Business Review. And I read a lot about the incubation of problems in our subconscious and how best to utilize that. It's so fascinating. And the little scenario that I paint for people to try to show what I think about the most is we've all been in a situation where a small part of a team or a small team are filing into a conference room to have a meeting, and certain people automatically sit at the head and the foot of the table. They are assuming they are the leadership. They're there to be respected, and other people sit along the wall, and they are implicitly saying, a lot of times, I'm not expecting to speak. I'm not expecting to be listened to. And so I feel like a very, very important thing we can do is break that paradigm and make the people who think that they have the most important voices speak less, and hear and listen more to the people who are heard and listened to less, because those people sitting along the wall, they're the ones who authentically wrote the code or held the soldering iron or whatever it was. Like, they know what really is happening on that granular level. And so I like to remind people of this it's a rule in certain Quaker business meetings, and I use it sort of as a guideline, which is that no one should speak twice until everyone has spoken once. And I think that's a very helpful thing for a lot of meetings just to keep in mind, so you hear more voices. So those are the kind of things that I spend a lot of time thinking about.
Beautiful.
Yeah, I completely agree. I think that's wonderful. And I'll mention Sandy Pentland's work. He looks at this, like, he calls it social physics, but he talks about idea flow. It's kind of looking at it from the network perspective, which is really interesting. And I think there's a lot to learn from the peacekeeping and conflict resolution communities as well.
I don't know that person's name. Can you say it again so I can look it up? Sandy
Pentland. He's at MIT Media Lab.
Okay, great.
Maybe you can drop it in chat.
Absolutely. Yeah. And thanks again.
Thank you.
Nico Sandlin, I have a quick question, but I don't want to.
And Rebecca has a
Rebecca.
question. I will try and find her and unmute her. So Rebecca, you can unmute and talk.
Yeah. Thank you for speaking, Lindy. This is a very interesting talk, and I quite appreciate hearing your perspective and as a different from the model.
Oh, wait, I'm sorry. I lost my internet for a second. Rebecca, can you start again? Apologies.
Sure, no worries. I just want to thank you. It was a great talk, and it's good to hear about your experience going through this.
Thank you.
And I want to ask a question. What inspired you to move from fieldwork centric research to a more data centric model like that that NASA spacecraft science does? Because we're not at a spot where we can just walk on the surface of these planetoids and other planets and pick up stuff.
Yeah, I mean, that I wish we had. I wish this was a lander and a sample return. So weirdly in my career, I've done a bunch of field work, but a lot of my work was experimental in high pressure and temperature labs. And then I did a whole bunch of theory just with code. So I sort of have spanned those three ways that we normally do science. And I had moved into leadership. I was a director at the Carnegie Institution for Science at the time that this possibility came along. I just got an email from a couple of people at JPL saying, we read this paper you published this year, And I wondered if you wanted to try to write a proposal to test your hypothesis using a space mission, which had literally never occurred to me. So we started putting together a little team, because that's the sort of thing you say yes to. Yes, let's find out what's the next step. And so I think the thing that really led me into the leadership of this is just my obsession with teams. And the reason I took the directorship at Carnegie and the reason I've gone on to take other leadership positions is because I think the question of how do you enable a whole team of people to do their jobs better and with more joy and more personal satisfaction and growth for each person is such an interesting question. And in a lot of parts of traditional academia, it is super underappreciated. So it was really the team aspect that brought me out of just doing the field work. And I'm all in favor of basic science, but for me, it had lost a little bit of its meaning. It wasn't a big enough impact for the amount of time that I was spending.
And then we have our
Very
director
cool.
of broader impact as a question. Sandy, you want
Sorry,
to
say again, Marav? I couldn't. Yeah.
we have our director for broader impact, Sandlin.
Hi, Lindy.
she had a
Thank you
question.
so much for your talk. Here's my question. I love your model of leadership and collaboration and teamwork. What advice would you have to kind of an early career person who may not be on a great team and how they could advocate or help themselves?
Oh my gosh, Sandlin, you must be so much more of an expert in this than I am. I'll add my little bit, but I would love to hear your top one afterwards. That would be fantastic. My very first go-to piece of advice in a giant string, and I shouldn't even call it advice, normally I don't, because honestly, I feel like what I'm doing is sharing my personal experience that can then become data points for other people to mix and match with their own personal experience. And so my go-to thing is to try to do what Ruth Bader Ginsburg did, which was you want to lead for change, but you want to lead in a way that other people want to follow. And I think it's very tempting. All of us come in, especially junior people, all of us, I think, have been harassed or bullied or misused or whatever it is, had bad experiences that went without any fair outcome. And we come in pre-enraged into our current situation, so that if then the next thing that happens that's wrong, we've got a kind of an overflow of emotion. And being able to control that emotion and communicate in a way that other people can hear you and that are inspired to follow is, I think, the key for starting to change a team from within. So that's my go-to advice. But what's your go-to advice?
I like the pre-enraged.
I think that's
Yeah.
such, I just love that, being the thing you want to be. And then
Yeah.
I think also reaching out to advocates like you and
Huge.
Marav and people, and just knowing that people exist that actually want to make change is super huge. And I think that's why we're so thrilled to have you speaking today. So.
I have
Thanks,
a
that's
quick
very kind.
question and regarding on thinking in a different way. And you touched it diagonally, that a lot of the science, it's not just the heroes that are elevated, but there is only one way of thinking, very analytic, and I saw you brought a lot of art into Psyche, but there is also a way, and I'm not sure what exactly is my question, but the way to be diverse in way of thinking. And that is a hard thing to change in a community. I don't know if you have any.
So hard. And I'm going to tell you something which I'm just even embarrassed to be saying, because I was so enraged when people used to say it to me, like, wait till you're a little more senior and then you can do all these wild things. And, I did start earlier, partly because I was 10 years older and I had a little more confidence in my position in the world. And also, I think people fetishize tenure. And sometimes, and you'll see this, sometimes people will fetishize tenure and they'll just spend their whole career trying to get tenure, and then they get tenure and then they're actually lost. It's like the academic midlife crisis. They're like, what the hell do I do now? And they want to win a prize, but prizes don't make you happy. Like, none of those things are good. And so I would say, keep pushing, but at the same time, you have to get the recognition of your excellence in your field, which ends up being a kind of a foundation upon which you can build many, many things. So that's one path. And I would not say you have to really wait until you're senior, wait until you have tenure, whatever is that, deadline in your head. But I would say focus on excellence while you push the boundaries. And if it's encouraging to anybody, I have found that every time I've done something that was not quite expected, like really start doubling down on the importance of team culture or incorporate a lot of art into what we do. A lot of people who'd been thinking it, but maybe had been focused somewhere else, get really excited. They're like, oh, that's a great idea. Everybody should do that. Just because wasn't the norm. And now I feel like it is. Now I feel like everybody can do all of these things. So maybe that's my real advice, is just go do it.
Oh, fantastic. Let's have one more question, and then we're also to the almost to the top of the hour. And I think we have Stephanie Jarmak. You want to unmute
Oh, hi,
and ask a
Stephanie.
question?
Hi, Lindy. Yeah, I wasn't able to make the entire talk, so I apologize if any of this was touched on earlier. But fantastic from what I saw.
Thanks for coming.
Yeah, happy to be here. Yeah, you're so clearly successful in so many different ventures as a leader and educator, scientist. Do you have any advice for like what tools or processes you use to facilitate your ability to be so successful?
Oh, that's nice of you. I have to say, I don't feel like success is a descriptor in my world for me. You know, I feel like I'm at a moment in my path, just like everybody is. And so I would say that at times in particular, when I felt like I was spinning my wheels or things are just not happening, it's to remember that if you just keep taking steps forward, trying to do things of high quality that are the most important things you can think of every day. What's happened for me is that then after a few months or at the end of the year or something, I look back and I'm like, wow, I actually made it some distance, even though I felt like I was just slipping on the scree slope every day. And so I would say being persistent, if not relentless, is the only secret that I know.
Wonderful.
Yeah, that's perfect. Thank you.
That was
Thanks.
super inspiring. Great chat. I have
Oh.
more questions, but I think we have to close it. I hope to have another chance to continue this conversation.
Thank you
And
for this. And thank
yeah.
you for everything that you all are doing, not just for science, but for teams.
Yeah, this is part of it's very, very exciting. It's the change you can see in the team culture and voices coming. It's
Love
super
it.
inspiring. Yeah, me too.
All right.
Anyway, folks, I hope to see you in the next Shield webinar, and this will be recorded so you can watch it the entirety if you miss some pieces. Bye, folks.
Thanks, everybody.